back to another chemistry video.
My name's Abel.
My name is Abram.
My name's Diego.
And this is our chemistry project.
W.
Alright guys, and in this little video that we got here, we're going to show the gas law demo project. In this little bottle right here demonstrates the volume, and we're going to change the temperatures demonstrating Charles' law. And here's my fellow young single assistant Diego. He's going to demonstrate that for us. As we can see, you can see the balloon slowly rising as the temperatures in the bottle increase, making the particles move faster, inflating the balloon.
Wow.
Alright, and according to Charles' law, if we dunk this hot bottle into this cold substance, all the particles inside the bottle, all the gases, will start slow down, deflating this balloon. And as you can see, the balloon right there is slowly deflating, moving into the bottle. And that's how you show Charles' law. And then here is Jaylene and Diego with our particle diagrams and energy bar charts.
Yo, what is up, guys? I'm Jaylene, and I'm going to be doing the particle diagram. Right, so in the before particle diagram, because the bottle was grabbed out of the ice, and ice is usually known for kind of being, frozen, you move slowly in the ice. The particles were moving slowly. They were still bouncing off the walls and everything, just moving very, very, very slowly. So, in the after particle diagram, once the bottle was placed in the boiling hot water, the particles began to move more frequently. They began to bounce off the walls more frequently. They began to move very fast, and they were moving farther apart. That is what caused the balloon to inflate just a little bit. You can't really notice too much, but it did inflate. Right, so now let's get to the after, which is when the hot bottle was placed into the cold ice water. So, because the balloon was inflating just a little bit because of the temperature increase, when the temperature decreased, that caused the balloon to deflate again. So, that's why in this particle diagram, the particles begin to slow down once more.
Thank you, Jamie, for that wonderful explanation of particle diagrams. I'm Abram Cunha, and I must say, the way she explained it was very, reflective, all shades aside. If you notice, during the initial explanation of the experiment, it was mentioned by Abel that Diego is single, so any takers? Going once? Going twice? Oh well, maybe next time. Speaking of Abel, our fearless leader, thank you so much for that explanation. Wow. Well done. Without further ado, here's Diego with his explanation of an energy bar chart, which unfortunately is not the type that you eat. Take it away.
What is up, everybody? My name is Diego, and I'm going to be explaining the energy bar chart. Alright, let's get started. So, as you can see, the initial temperature of the bottle was cold because we had put it in a refrigerator to keep it cold for the experiment. And the initial phase energy for it was 4 bars because it's a gas that's in the bottle. Okay, so, and as you can see, when we put the bottle inside the hot boiling water, the thermal energy rose to 4 bars because it became very hot from being inside of the bottle, which made it gain 3 bars of energy because it went from 1 bar to 4 bars of energy. And the phase energy stayed the same because there was still a gas inside. No new substance, or it didn't condense or anything. It just stayed a gas like how it was originally. Okay, to demonstrate the second part of the experiment, where the balloon is shown shrinking in size because the temperature of the bottle was decreasing. So at the beginning, of that part of the experiment, we started with 4 bars of thermal energy because, again, the bottle was sitting inside of boiling hot water and it was very hot. And the phase energy is still gas because there's only gas particles inside of the bottle, nothing else. And as you can see, 3 bars of thermal energy leave the bottle because we put it in cold water, which decreased the temperature of the bottle down to 1 bar of thermal energy, making it very cold. And again, the phase energy stayed the same. It was still a gas, nothing else. Thank you. And subscribe.